Hello guys, how are you doing? So today we'll be finding out the application of mathematical operators in Swift. That is, in how we can use these mathematical operators in real life. So I've put up a video, quick introduction to that. I'll send the link down below. So it discusses about the mathematical operations you can use in Swift. But we'll be looking, in this video we'll be looking about the applications of it. So without further ado, let's dive right in. Our first problem is finding the area and perimeter of a square. So the variable side of squares shows the side value. Area and perimeter, we have to set these to set the area and perimeter of the square. Let's give it a random value of 5. Now, as we know, the area of a square is just side of square multiplied by the side of square. Pretty simple. We are using the multiplication operator here. This just multiplies this and this, the left hand side and the right hand side. The perimeter is just 4 times the side of square. This is also the multiplication operator, just multiplying this and this. So finally we can print out the area of the square and the perimeter of the square, which should be 25 and 20. So here. So we move on to the next problem. Find the area and the perimeter of a rectangle. The variable length and the variable breadth store the values of length and breadth respectively. The perimeter of the rectangle, we have to set it so that it shows the perimeter, and the area should show the area. So we have that the perimeter of a rectangle is twice the sum of length and breadth. So we can just do it like length plus breadth. However, it won't work because it should be 2 multiplied by the sum of length and breadth. But first, let me initialize the value of length and breadth so that this error does not show up. Let's give this some random value of 12 and then let's say 6. So you can use brackets too to compute mathematical operations. Swift takes care of the order of operations, and what it will just do is first compute the brackets, that is what's inside the brackets is first find the sum of length and the breadth, and then multiplies it by 2. That computes the perimeter of the rectangle. The area of the rectangle, it's pretty simple. Length times breadth. So as you can see, if we run it now, we can see the perimeter and the area of the rectangle. You can check that these are in fact true. So let's move on to the next problem. Find the volume of a cube with edge length edge. Now the volume of a cube is just edge cubed. So if I give some random value, let's say 20, so the volume should be pretty simple, edge times edge times edge. However, please note that this is very inefficient way of doing it. So I mean, we have 3 values and we have to type all of them separately. I mean, that's kind of lengthy, but we can still manage it for the purpose of this exercise. So edge times edge, that's just edge cubed, and it's just volume of the cube. So I mean, so yeah, so if I print it now, I should get 20 times 20 times 20, or 20 cubed, or 8,000, as you can see here. Yeah, you can even maximize it. So yeah, so we move on to the next problem, which is a generalized version, you can say. So compute the value of x power to the power of y. So I've already given some intro values, 23 and 8. So UIKit has an standard library function pow. The pow function goes like this: pow x y. This just computes x times y and stores in value, and I'm storing it in a value x pow y. So yeah, so I just have to do pow x and y. So I can indeed replace this let edge times edge times edge to pow. I will show you why we need this decimal later. Edge 3. So if I run it now, I should still get the result of 8,000. So as you can see, I still get the 8,000. Notice how it's much more effective I mean on the long term. So if I can change it to like say 10 and something like that, and it will still work. We don't have to add anything else. So yeah, so if I just print x power y, it should give us 23 raised to power 8. 20 should be 78131, something like that. Yeah, you can see it on the output. It's pretty simple. But notice we have a decimal and we have enclosed it in x. That's because the power function takes in a decimal in the first argument. So we just need to typecast it to decimal. Okay, next problem. We are given x. Let's say we give a random value of x to, let's say, 90. We need to find the value of x cubed plus x minus 1. So we can just do a decimal x in 3. This computes x cubed, the first part of the expression. We now have to add x, so just say x minus 1. So indeed, if I run it now, we should get, I'm getting an error here, binary operator plus cannot, okay. So what this gives me is because it's a decimal, so and x is an integer, so if I say it like that, if I have to typecast it, that should work, because Swift can only add the decimals and decimals together. I mean, you can't add an integer to a decimal and like that. An easier way of doing it would be x times x times x, but again, that's not really effective on the long term. So if I change it to this, it first computes x cubed, which is x times x times x, plus x minus 1. This gives us the value 729089, like this. So I was showing you the power implementation of it, power decimal x and 3. Okay, now we say answer plus equals to x, or answer minus equals to 1. So if I do it now, I should first change it to arvlet. So we have learned why we need to do it in an earlier video. So I first have to change it to decimal, because it's again in decimal, double and double. Okay, so yeah, so this computes the answer for this, so we just have to change it to decimal, and this will compute the answer for this. So this, just add up to the, just compute the power first, then add up to the decimal, and then subtract 1 from it. So it computes the value of x cubed plus x minus 1, and we just print it to the answer. So if you can see now, is printing. So yeah, so we get 729089. You can also just combine it into plus 1. I have to write this decimal because all these are integers. So all these are integers, so I just cannot add an integer and a decimal together, because Swift is really safe, and type safety cannot be risked. So if I add decimal and integer, this will just give me an error. Although I don't need to add decimal to a 1, because Swift can already tell that it's a double, because yeah. So we get 729089. I hope everything is clear up to now. If you didn't understand anything, please leave it in the comments. So here we move on to the exercise. Find the value of a sphere where the radius is stored in a variable r. So I've written brute force here because, I mean, r cubed, you just can't go r times r times r. But yeah, you can use the pow function. This will be a better way of doing it, but you can just do it. Volume of a square is just 4 by 3 times pi times r cubed. That's the exercise for today. If you can't complete it, please write it in the comments and I'll answer your queries. Thank you for watching. Catch you guys later.